The infinite universe has fascinated and intrigued humans since the dawn of time. The more we look, the more we learn about everything that exists beyond the Karman line. The planets, the moons, the never-ending galaxies, and a host of things we can't even imagine yet. The Dawn mission launched by NASA in 2007 attempted to define the processes that dominated the early history of the solar system. Dawn visited two time capsules of the solar system, Vesta and Ceres. Today we're going to look into the discoveries that NASA's Dawn has made, so join us. Vesta and Ceres are the biggest asteroids in the main asteroid belt. Scientists gained insight into the solar system's fundamental building elements by studying these planet-like rocks, which are intact survivors from the solar system's early past. In addition, by mapping the bodies from orbit, the spacecraft was able to offer vital data that scientists could not obtain using telescopes or quick flybys. Dawn demonstrated the significance of birthplace for bodies in the early days of our solar system, which originated 4.6 billion years ago. It made evident that knowing the environment in which the smaller planets evolved is critical to understanding their fate. Models of the early solar system and planetary migration must now account for the discoveries made by Dawn over the previous 7 years. Vesta, which most likely originated and remained in the inner solar system, developed in many ways similar to the inner solar system's stony planets. Dawn's survey of Vesta's craters revealed that the northern hemisphere of Vesta has an older surface with more major impacts than predicted, based on pre-Dawn models of asteroids in the main belt. This implies that there were more huge objects early on that planetesimals, the sorts of smaller entities that potentially grow into planets, were born enormous rather than being made of smaller bits. Ceres, on the other hand, appears to have developed distant from the Sun and moved into the inner solar system. Dawn studied Ceres' surface chemistry and discovered a molecule, ammonia, that needs the lower temperatures of the outer solar system beyond Jupiter's orbit to form. Ceres might have developed there and subsequently moved closer to the Sun. Or debris from the outer solar system might have migrated inward and clung to Ceres as it developed. Dawn further emphasized that the amount of water integrated in solar system bodies is determined by their position, and that water is crucial in pushing away heat. Ceres' body cooled quickly since it was produced with so much water. Those who had little or no water, such as Vesta, were unable to cool as quickly. Vesta's interior was entirely melted, creating a metallic core, rocky mantle, and crust. Ceres' interior, on the other hand, is stratified with a rocky mantle composed of water-rich rock, such as clays, and an exterior shell composed of water in the form of ice and hydrates. Ocean planets are a subject of space research because they may offer life-supporting conditions. We know that there are a slew of moons that have seas, including Saturn's moons, Enceladus and Titan, as well as Jupiter's moon Europa. Ceres is an important component of the jigsaw that is the aquatic world. Ceres seems to be a leftover ocean planet, wearing the chemistry of its previous ocean and traces of the interaction on its surface, with a crust that blends ice, salts, rock-forming minerals, and other elements. Dawn's findings indicate that some brackish liquid may still be beneath the surface. As a developed dwarf planet, Ceres can educate us about the environmental conditions on other ocean planets. Organic molecules are the building blocks of life, and Dawn discovered an abundance of organics exposed in the Ernutet crater area. The Dawn team believes they originated in Ceres' interior, probably developing in the dwarf planet's deep ocean. Dawn also discovered an aliphatic organic molecule composed of carbon and hydrogen chains. While these organics were discovered in a very small area, Ceres' loose surface material contains a large amount of carbon on a global scale. However, scientists are still unsure about the origins of Ceres' organic compounds. Organics are typically connected with life on Earth, but they can also be related with non-biological activities throughout our solar system. Science fiction has given us pictures of multi-destination spacecraft and Star Wars TIE fighters, which stood for Twin Ion Engine. Thanks to its own ion engines, Dawn is the only spacecraft to orbit two deep space destinations. Dawn became the only spacecraft to circle a body in the main asteroid belt between Mars and Jupiter when it entered orbit around Vesta in 2011. Likewise, Dawn became the first spacecraft to visit a dwarf planet and the first spacecraft to orbit one when it entered orbit around Ceres in 2015. While Dawn was not the first interplanetary spacecraft to deploy ion engines, that claim goes to NASA's Deep Space One. It pushed this technology's possibilities further. Dawn holds the record for the longest period of powered flight, 6 years, and the biggest velocity change, 25,700 miles per hour or 41,400 kilometers per hour, accomplished by a spacecraft with its own propulsion system. While the massive basin in Vesta's southern hemisphere, now known as Rhea Silvia, was visible to Earth-based observatories, Dawn proved its size, more than 310 miles, 500 kilometers in diameter, and 12 miles 19 kilometers deep. Moreover, Dawn revealed that the peak visible by NASA's Hubble Space Telescope at the basin center is twice the height of Mount Everest. It is the second highest peak in the solar system, nearly as tall as Mars' Olympus Mons. Dawn's close-up examination discovered a second massive impact basin, now known as Venonea, that was largely hidden under the younger Rhea Silvia basin. Vesta's surface was changed and presumably devastated as a result of this 1-2 blow. These massive impacts carved out dozens of gorges, seen in Dawn's photos, that circled Vesta's equator, with an older set in the northern latitudes. Some of these canyons are as long as 290 miles, 465 kilometers, and as deep as 2.5 miles, 4 kilometers, rivaling the Grand Canyon in scale. Dawn's findings also reveal that the catastrophic impact that created Rhea Silvia happened barely a billion years ago, causing large volumes of debris to shower back down on the surface. As a result, the surface of the southern hemisphere seems younger than that of the northern hemisphere, which has a rich record of craters. Before Dawn, astronomers thought of Vesta as a largely dry world, but Dawn discovered water-rich materials on the planet's surface and carbon-rich materials seen in Vesta meteorites. These materials were most likely brought to Vesta by asteroids or comets from the more volatile outer solar system. Ceres is home to a brilliant variety of around 300 luminous features known as faculae, and formerly referred to as bright spots, that dazzle over an otherwise black surface. In addition, Akator Crater's brightest region has the greatest amount of carbonate minerals ever observed outside of Earth. These minerals are found in the oceans and lakes on Earth, but according to the results, salts were deposited on Ceres' surface by briny water that came to the top recently. The bright patches were discovered to be deposits of sodium carbonate, a combination of sodium, carbon, and oxygen. They were most likely formed by fluids that percolated to the top and evaporated, leaving behind a highly reflecting salt crust. But they hadn't figured out where that liquid originated from. After examining data obtained towards the mission's end, Dawn scientists decided that the liquid came from a deep reserve of brine, or salt-enriched water. Scientists learned more about Ceres' interior structure by examining its gravity, and they were able to establish that the brine reservoir is around 25 miles, 40 kilometers deep and hundreds of miles broad. Unlike other of the ice moons of the outer solar system, Ceres does not benefit from internal heating caused by gravitational interactions with a big planet. However, the current study, which focuses on Ceres' 57-mile wide, 92-kilometer wide, Akator Crater, which has the most widespread brilliant patches, indicates that Ceres, like these other frozen planets, is a water-rich world. The discoveries, which also disclose the breadth of geologic activity in Akator Crater, were published on August 10 in a special collection of articles edited by Nature Astronomy, Nature Geoscience, and Nature Communications. Ceres is home to a massive volcano known as Ahuna Mons, which the Dawn team thinks developed as a cryovolcano. This lonely mountain, 3 miles 5 kilometers high on its steepest side, shows that liquid may still exist under Ceres' surface. However, the more recent geologic activity is most likely caused by liquids richer in salts, which reduce the freezing point. How far has space exploration come? Do you think we'll discover life beyond Earth soon? Let us know in the comments below. See you at the next one.